Hi, ladies. Um, Instead of moving on to cube roots and square roots, we're going to actually continue on with a few new exponent rules. I decided to switch things up a little bit, and this seemed to make a little bit more sense. So I know I said your next set of notes would be on cube roots and square roots, but I take that back. It is now, we're going to do a little bit more with the exponents. So in our last exponent lesson, we talked about negative exponents, all right? And we talked about when you have a negative exponent, you basically flip it. So if I have x to the negative second, whenever you have a negative exponent, you find the opposite. So example, this is really x to the negative second over 1. You flip it, and it becomes positive. So x to the negative second really equals 1 over x squared. You flip them and make it positive when it goes in the denominator. And that was a rule that we learned in the last section. All right. We also learned the zero exponent rule. And the zero exponent rule just says anything raised to the 0 power is 1. Okay? A million raised to the 0 is 1. 5,000 raised to the 0 is 1. 60 raised to 0, 1. Okay? So we learned the first two rules in our set of notes last time, and we also learned how to just write exponents, right? 2 times 2 times 2. We can write that as 2 to the third. 5 times 5, we can rewrite that as 5 squared. Now, there's a few more exponent laws that you have to know, okay? Sorry about that. And we're going to get into those today. So one rule that you need to know is the product rule. The next rule is quotient rule. Then we have a power rule, and then power of a product rule. So these 6 exponent rules you have to know. We did 2 in the first lesson, and we're going to do 4 today. The product rule. When two expressions with the same base, remember we talked about this is a base, that is the exponent. So when two of them are multiplied together, and they have the same base, so they both have a base of x, you add exponents, okay? Add the exponents. So let's practice with some of these. Rewrite the following expressions. We don't have to worry about evaluating them. I just want you guys right now to practice rewriting them. X to the third times x to the sixth. Now they both have the base of x, and you add the exponents. So 3 plus 6 is 9. The next one, they both have a base of 10. So you keep the base, and you add their exponents. 2 plus 5, 7. The next one, they both have a base of 2. So when I multiply, we add exponents. So 3 plus 5 is 8. Okay. The next one is something a little bit different. So now I added a coefficient in front of the bases. So really, x to the second and x to the seventh are the ones with the exponents. So in this case, we multiply the coefficients, which are 5 and 2. The base is, remember the base is whatever is being raised to the exponent. So in this case, 5 and 2 are not being raised to the exponent. The x's that have the exponents with them, and the x's are the same base. So we keep the base, add exponents. 2 plus 7 is 9. So again, only the x's are being raised to an exponent, not the 2, not the 5. Similarly, E, the x's are being raised to the exponent, not the -2 and the -3. Now, -2 times -3, they're the same sign, so it's positive. X to the 6 plus 4 is 10. All right, last one here. Again, these are a little bit more tricky, but the x's are the ones that are being raised to the exponent, not the 6, not the -2. So the 6 and the -2 are just numbers that will get multiplied. 6 times -2, -12, x to the 5th. All right, so that's your first rule. When you multiply exponent, well, I apologize. When you multiply expressions, you add the exponents when they have the same base. So all these have the same bases. Actually, this had a base of x, base of 10, base of 2, base of x, base of x, base of x. The base is what's being multiplied, I'm sorry, being raised to the exponent. All right, let's try the next rule. The next rule is the quotient rule. And you guys know that quotient means to divide. Just like product, oops, meant multiply. So if we added the exponents when we did the product rule, when we do the quotient rule, we subtract exponents. So when two expressions with the same bases are divided, you subtract the exponents. So let's look at A. A, the bases are A's, so the same base. Now subtract them. 8 minus 2, 6. All right, let's show the next one. Both have a base of x. 5 minus 3, 2. All right, in this case, there's two things. We have a base of x and a base of y. It's okay. We just lump together our same bases. So our x's would be 8 minus 4, which is 4. My y's would be 10 minus 2, which is 8. So you just lump together your similar bases. It's okay that we have two of them now. Just subtract all the x's and subtract the y's. All right, let's scroll down here. Oh, so I put another step into this. Again, bases are the x's here. The numbers are divided like normal. They're just numbers. 25 divided by 5 is 5. X to the 6 minus 3 is 3. So the numbers, the coefficients that I'm adding in, we just treat as numbers. You multiply them or you divide the numbers. It's the exponents that have different rules. So E, 10 divided by 2 is 5. X to the 5th. 9 minus 4 is 5. And last but not least, I threw 3 different ones in here. No big deal. Coefficients, simple. They're just numbers. We just divide them. 18 divided by 2 is 9. X to the 7 minus 2 is 5. Y to the 6 minus 3, 3. So that is the second new rule that you guys need to know. Quotient rule. When you divide exponents, you're actually just subtracting them. When you multiply exponents or expressions with exponents, you add them. Our third rule is when you have a power to a power. I think this one will be best seen by example. So let's rewrite these ones. And I want to show you what's going on here. When it's a power to a power, that means that you have a power inside, you have an exponent inside and an exponent outside. So I just want to show you guys something. X to the 6 raised to the third is really x to the 6, x to the 6, x to the 6, right? Which is really 6x's, 6x's, and 6x's. So 1, 2, 3, 4, 5, 6 from that one. 1, 2, 3, 4, 5, 6 from that one. 1, 2, 3, 4, 5, 6 from that one. So all together, when I add all my x's here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 x's, which isn't 6 times 3, 18. It is. So that's where that comes from. When it's a power to a power, you multiply. Let's try B. Y to the third raised to the fourth. You multiply 3 times 4, which is 12. And next one, x to the second raised to the third. 2 times 3, 6. I don't know that I have any more examples for that one, no. So that is a power to a power rule. Now let's look at one last rule. I know there's a lot of rules. These are the 6 exponent all together, the 6 exponent rules or laws that you have to know. If you have 2 things in the parentheses, right? It just, the exponent on the outside gets multiplied to everything on the inside. What I mean by that, let's look at an example. Xy squared. Think about that. That's really xy, xy, right? It's 2 of those terms, which is really 2 x's and 2 y's. So xy squared, when it's on the outside like that, really just x squared y squared. Okay, now same with the next one. X to the 7th, y to the 8th. X to the 7th, y to the 8th. Well, all together, I have 7 plus 7 x's, which is 14. I have 8 plus 8 y's, which is 16. Which, wait a minute. 7 times 2 is 14. 8 times 2 is 16. All right, that makes kind of sense, doesn't it? Last one I want to throw out to you, really throwing everything together here. 5x, and you do not have to write these out like this. I'm just trying to show you where this is coming from. So 5x to the third, y to the fourth. 5x to the third, y to the fourth. There was a reason that I chose exponents of 2 for this, so I could actually show you. Because if I made that number on the outside like 15, man, I would not want to write that term 15 times. So remember, when you multiply, numbers are numbers. Coefficients, which are just numbers in front of variables. So for example, here, 3 is the coefficient. It's the number in front of the variable. So coefficients for this are just going to get multiplied. 5 times 5 is 25. X to the third times x to the third. We know when we multiply, we add exponents. y to the 4th times y to the 4th is y to the 8th, because 4, oops, oh goodness. 4 plus 4 is 8. So that's what our answer should pan out to. Now let's see. This is saying that everything inside is getting squared. So 5 squared, x to the 3 times 2 is 6. Y to the 4 times 2 is 8. And to simplify just a little bit, 5 squared is 25. X to the 6, y to the 8th. When I wrote it out, it was the same thing, right? Purple and red match. So if the exponent's on the outside, then everything's technically getting squared, including the coefficients. But when it's a power to a power, you multiply, and 5 squared is 25. Coefficients would get squared, or whatever, raised to the power, whatever that is. Whew, man, those are a lot of exponent rules, huh? We will go over all of the exponent rules on Monday. Do not stress about them. Make sure to just look them over. This chart, you will need to know the whole thing. So take some time, look it over, get to know it. But we will go over these again on Monday. So if you have some free time this weekend, maybe study your exponent rules. But other than that, I will talk to you guys on Monday. Have a great weekend.